we have basically the carriers as electrons and holes. So holes and electrons are the carriers. They are moving from one point to another point, and their movement, their phenomenal movement is basically creating a large number of effects. और उन्हीं सारे इफेक्ट्स को हमने स्टडी किया, उन्हीं सारे इफेक्ट्स को हमने अलग अलग एप्लीकेशन में इनकॉर्पोरेट कर दिया. अब इन्हीं सब सीक्वेंस के बीच में जो हमने पिछली टॉपिक पढ़ा था, जो पिछला थियोरिटिकल पार्ट हम लोग पढ़ रहे थे, दैट वाज रिलेटेड विद द जनरेशन एंड रिकॉम्बिनेशन. तो अब एक चीज हमें समझ में आई, जनरेशन मींस जनरेशन ऑफ चार्ज कैरियर्स. Recombination मतलब charge carriers are recombining each other and making a covalent bond. So recombination is forming a covalent bond, and generation means creation of electron and hole pairs. So electron hole pair generation and the recombination, these two factors are working simultaneously. When these two are working simultaneously, then this phenomena is creating a large number of effect. अब हुआ क्या, ये फिनोमेना हुआ था, तो हमने कहा अगर रिकॉम्बिनेशन ज्यादा हो गए तो कोवलेंट बॉन्ड बन जाएगा, चार्ज कैरियर्स खत्म हो जाएंगे. और अगर जनरेशन ज्यादा हो गया तो लैटिस पूरा टूट जाएगा, ब्रेकअप हो जाएगा. मतलब आपके पास में एक डायोड है, तो आप थोड़ी बार देखेंगे वो डायोड खत्म होने लगेगा, डिकेज होने लगेंगे, जैसे रेडियो एक्टिव एलिमेंट्स के अंदर डिकेज होते हैं रेडिएशन की वजह से. तो ये इम्बैलेंस सिचुएशन थी. इस इम्बैलेंस सिचुएशंस के लिए कहा गया नो, इट बैलेंस ऑलवेज. Rate of recombination and rate of generation always remains same, and this situation is called as an equilibrium situation. And under this equilibrium situation, the basically mass action law, which is Np n equals to Ni square, always follows. That we have already studied about, that we have already talked about, that this Pn equals to Ni square always works upon. ये हमेशा काम करता है. This is working all about. So when this particular kind of equilibrium situation is working, then we try to find out, is there possible to change some equilibrium state? Then we got an answer. Yes, it is possible. You have to inject. There's an injection process. Doping is one thing. You have doped and you have created. After some time, it will go in an equilibrium situation. But if you wanted to create a thermal in equilibrium, so you have to put it to injection state. So we created this particular equation and we got that result that this happens in like a way. Like this is the sample. ये वो तरीका है जिसकी वजह से यहाँ पर जनरेशन और रिकॉम्बिनेशन होता है, and we found that this particular decay is like that, and on the basis of that last time we have created this wonderful equation that Pn T किसी भी टाइम पर Pn नंबर ऑफ होल्स किसके बराबर होंगे, Pn नॉट, जब वो इक्विलिब्रियम में था. If suppose we have in equilibrium 100 of holes, now after time t, certain time, after 5 minutes, after 2 minutes, after 4 minutes, what will be the number of holes in the material if it is in equilibrium situation? Then this comes up with the help of this relationship. So that we got here. And finally we talk about that this particular process will lead up this problem. So now coming to the second section, which is called as an indirect recombination. So like that was a direct recombination, we talk about that. Now we are looking for the indirect. Direct and indirect is depending upon basically the thing in which direct band gap semiconductors and indirect band gap semiconductors works. So if suppose we have a direct recombination, then direct band semiconductor works. So remember this point always, that in direct if talking about the direct recombination process or direct generation process, direct recombination process, direct band gap generator works, semiconductor works. And if you are looking for indirect recombination, so we have to take care about that this terminology, that we have indirect band gap semiconductor. So it's a very simple phenomena, just making it clear. Such as silicon, a direct recombination process is very unlikely. Generally नहीं होगा, सीधे सीधे recombine हो गए, नहीं होगा, because the electron at the bottom of conduction band have non-zero momentum with respect to the holes at the top of the valency band. This is a very interesting line. Bottom of conduction band have non-zero momentum. Like we have this conduction band, we have valency band. In conduction band at the bottom, momentum is almost have a non-zero momentum with respect to the holes. So this has a momentum, somewhere momentum is here. But respect to the holes at the top of the valency band, direct transition that converses both energy and momentum is not possible. So we talked already about that. This is not aligned. This momentum is not aligned. If we go for the previous theory, indirect semiconductor band gap has that kind of situation. It means conduction band is here, valency band is here, and there is a gap. This situation not here. So what happens? We are talking this momentum with respect to the holes at the top of the valency band, a direct transition that conserves both energy and momentum is not possible. इनका यहां से यहां जाना और इनका यहां से जाना पॉसिबल नहीं हो पाता. क्यों? क्योंकि कंडक्शन बैंड अगर सपोज करो यू बना हुआ है तो वैलेंसी बैंड यहां पर यू बना हुआ है और ये अनअलाइंड है, एक दूसरे के साथ में नहीं है, अलाइन नहीं है. लेकिन डायरेक्ट बैंड गैप में ये अलाइंड होते हैं, ऐसे होते हैं. तो इसीलिए इनका ट्रांजिशन सिंपल होता है डायरेक्ट में, और इनडायरेक्ट में ये नहीं होता. इनको इंटरमीडिएट स्टेट चाहिए होती है. वी हैव ऑलरेडी टॉक्ड अबाउट दैट. Therefore, the dominant recombination process in such semiconductor is indirect transition. तो इस टाइप में क्या होता है? Indirect transition होता है. Therefore, transition via localized energy state in the forbidden energy gap. These states acts as a stepping stone between the conduction band and the valency band. So we have something in between. You see here, like this is the situation. Just take an example with the help of this diagram. Like here we have this EV, valency band. Here we have conduction band. Talking about the combination, we have some intermediate state talking about this one. So first of all, instead of it moving from the valency to directly top level, it has to stay with the some middle energy. This energy is T. So before state and the after state, two states are here. If we see in this diagram, take it complete diagram, look. So state are here. If suppose we have a before state and the after state, so here we have basically the four section: electron capture, electron emission, hole capture, and hole emission. So see, it's really very interesting diagram. If you see here, under this situation, electron capturing process. Electron capture, it means a hole is about to capture electron. Here, electron emission, it means a bond is broken up, electron is getting free and going up. So clear? Capture and emission, very clear. Capture means electron जाके कोवलेंट बॉन्ड बनाएगा, और एमिशन मींस इलेक्ट्रॉन फ्री होगा कोवलेंट बॉन्ड से और ऊपर जाएगा. कोवलेंट बॉन्ड से फ्री होके ऊपर जाएगा, ये प्रोसेस कहलाएगा आपका एमिशन. सी, सो हियर वी हैव फर्स्ट ऑफ ऑल इलेक्ट्रॉन कैप्चरिंग प्रोसेस. दिस इज द इंटरमीडिएट स्टेप. सो इलेक्ट्रॉन स्टार्ट्स फ्रॉम कंडक्शन बैंड. कंडक्शन बैंड से वो शुरू हुआ, शुरू होके कहाँ आया? इंटरमीडिएट स्टेट में आके यहाँ कैप्चर हो गया. एमिशन प्रोसेस में होगा, जहां वो कैप्चर था इंटरमीडिएट स्टेट से, वहीं से एमिट हो जाएगा, बीच से चला जाएगा. सिमिलरली यहां से होल का कैप्चर, होल कैप्चरिंग, इट मींस द होल इज रिटर्निंग बैक टू वैलेंसी बैंड. होल वापस वैलेंसी बैंड में आ रहा है, वहां पहुंचा है. दिस इज कॉल्ड एज अ होल कैप्चर. एंड होल एमिशन, so when this hole reaches to this position, so hole is comes to intermediate state. So under the situations we have basically four: electron capture, electron emission, hole capture, hole emission. So we have basically the four stages are there, and every time this intermediate step ET is the energy level. That intermediate state is not somewhat like a place. कोई table नहीं रखी कि valency band यहाँ है, conduction band यहाँ है, table रखी. No, it's not like that. It means the electron and holes are already there, but they are having a level of energy. पहले क्या हो रहा था? पहले हो रहा था कि लेवल ऑफ एनर्जी कुछ इस तरीके का था. जैसे ही इलेक्ट्रॉन एंड होल्स को एनर्जी मिली, फटाक से कंडक्टिंग हो गए, चलने लगे. अब वो इतनी एनर्जी मिली कि कंडक्टिंग नहीं हो पाए. इट रिक्वायर्स मोर एनर्जी, बट इट इज स्टेबल इन दैट सिचुएशन. दिस इज कॉल्ड एज इंटरमीडिएट स्टेट. एनर्जी मिल गई उसको, तो उसको एनर्जी के रेफरेंस से हमने कहा कि बीच में आ गया. बाकी ये स्केल तो वही है, जगह वही है, फिजिकली दे आर वेयर, कहीं नहीं जा रहे, डिब्बा छोड़ के नहीं जा रहे, छत छोड़ के नहीं जा रहे. इफ दे आर लाइंग ऑन द सरफेस ऑफ दिस वन, दे आर ऑन हियर, ये यहीं पर ही है, दे आर नॉट गोइंग एनीवेयर, उसी सरफेस पर है. बट इनकी एनर्जी का फर्क पड़ रहा है, एनर्जी कम और ज्यादा. सो दे आर हैविंग अ डिफरेंस ऑफ एनर्जी. सो दिस इज बेसिकली द मीनिंग ऑफ दिस डायग्राम. I hope you are able to understand this diagram. Meanwhile, if you feel doubt, you may ask. Begin more. So this recombination is there, and we were having a discussion on this part. So same thing we read up here. Figure 12 shows various transitions that occurs in the recombination process through intermediate level state, also called as a recombination centers. Exactly, this is the point where भाई जैसे आप अपने अपने घर से निकलते हो, somebody just moving और कहा कि नहीं मैं तुम्हारे घर नहीं आ सकता, मैं तुम्हारे घर नहीं आ सकता, okay fine, let's meet at some middle point, कहीं बीच में मिल जाते हैं. So it's like that. So shows various transition that occurs in recombination process through intermediate level state, also called recombination centers. So this is stated through charging state and center before the after each of the four basic transitions takes place. The illustration is for the case of the recombination center with single energy level, that is a neutral. So the same thing is here. We are talking about the single energy level neutral. It might be possible इस तरीके की intermediate state बहुत सारी हो, मतलब आपके घर से लेके if suppose you have a house somewhere and somebody is coming, so it might be possible not only the fixed position is there, it may be possible some may be shifted here, some may be shifted here. Intermediate की state कहीं भी हो सकती है जहां पर जाके आप लोग मिल रहे हो, जहां मिल सकते हो. So that is what intermediate state may have a varieties, बहुत सारा हो सकता है. When do not occupied by the electrons, or negative when it is occupied in indirect combination. So if we go for this one, it's a very good formula. If you just compare this formula with the previous one, so that is also taken here, not going in a much detail about that. So this U under this case is depending upon what? VTH, it means drift. Sigma n, conductivity of electron. Sigma p, conductivity of hole. And T is the concentration at that particular point of time. What is that? So if we go for this, NT is the concentration of recombination center. So what we have recombinations, उस recombination center पे कितने लोग मिल रहे हैं? जैसे if suppose somebody is coming from his home, another body is coming from his home, और मिलने की जगह कहाँ पर fix हुई? Like suppose we have at the Domino's center, Domino's pizza center में मिल रहे हैं. तो Domino's pizza center is that intermediate state. And how many people are there? How many people are there? That has to be taken into consideration. वो भी देखना पड़ेगा कितने लोग वहां इकट्ठे हो गए. So this NT is the concentration of recombination centers. That is, and Pn, Nn you know, Ni square you know, and rest of the values you simply know about that energy level. So by this recombination rate can be calculated. So this is just only for the purpose of your reference, not go for any detail, but actually to make you understand how it takes place. So this is only the part I'm taking up here. Now coming up to the next one, which is most important. If somebody asks you what are the other options, the first, direct recombination, second is the indirect recombination, and third is what? Surface recombination. So talking about this one, see, this is a very beautiful diagram. You might be able to understand this one. This one. And this particular is showing the lattice of the silicon. And here at some points, we should have some surfaces. Talking about these surfaces. So just keep this surface in a mind. This is a surface. Internal S's are there. Internally, they are connected with the bond. And we are having a certain points. Obviously, all the faces are not the surfaces. सारे के सारे face surfaces नहीं होते हैं. ठीक है? So talking about only those one which are having these surfaces. So under this situation, we are talking about and watching this, that how it is working upon. So let's see, discussing about what exactly the surface one. So checking this, the bonds at the semiconductor surface, because of the abrupt discontinuity of the abrupt, मतलब uniform नहीं है, surface पर uniform नहीं है, abrupt discontinuity of the lattice structure at the surface, a large number of localized energy state और generation recombination center may be introduced of the surface. तो कितनी अच्छी बात पता चली, मतलब आपके घर की छत पे ऐसे पॉइंट्स बन गए हैं जहां पर लोग आगे मिल सकते हैं. सीधी सी बात है. Like they are not walking through the roads. आपका घर है, आपकी छत है, सामने वाले की छत है, they are connected with each other, and at the point of some surfaces है, छत की surface है, and the peoples are coming and meeting at the point. चलो उसकी छत पे मिलते हैं, चलो उसकी छत पे मिलते हैं, like that. That's an example. तो इस तरीके की सिचुएशन क्रिएट हो रही है बिकॉज ऑफ व्हाट, लैटिस स्ट्रक्चर में सरफेसेस के ऊपर एबनॉर्मलिटीज होती हैं और ये एबनॉर्मलिटीज जो होती हैं वो इंटरमीडिएट एनर्जी स्टेट क्रिएट कर देती हैं। ठीक है, एनर्जी स्टेट और जनरेशन रिकॉम्बिनेशन सेंटर, वहां पे जनरेशन रिकॉम्बिनेशन सेंटर बना देते हैं, मे बी इंट्रोड्यूस एज अ सरफेस रीजन। दीज एनर्जी स्टेट्स आर कॉल्ड एज अ सरफेस स्टेट्स। may greatly enhance the recombination rate at the surface region। तो सबसे ज्यादा रिकॉम्बिनेशन सरफेसेस पे होने लगते हैं। The kinetics of the surface recombinations are similar to those considered before the bulk center. The total number of the carrier recombination at the surface per unit area and unit time can be expressed in the form of analogous equation number. This is the equation is given. So same equation can be taken from the like indirect or direct band gap semiconductor. This is just only a rate of combination. So ultimately this particular paragraph is giving idea that what is surface recombination. Just brief it out. Surface recombinations are basically some at the surface of the semiconductor. Abrupt changes are there, and because of this abrupt changes, some local centers are created. Local word इसलिए use करते हैं, they are not permanent. Somewhat they may be changed. So local centers may be created और वहां पर recombination और generation process generally surfaces पर होते रहते हैं. This is exactly the surface. So here we are just taking a surface examples are here, like in this one. Another, like talking about the recombination in the same one. So if suppose we have EV, EC, so when this electron is just reaching back, वापस आ रहा है, तब जाके it is just meeting into the V valency band and creating a recombination. So this is the basically another phenomena related with the Auger recombination, and we'll go for this Auger recombination in the next topic. More about that. So I'm just briefing this one because it's already now time. So I'm briefing this one for you, what exactly we have studied about today. And if we suppose we talk the same talk in the case of semiconductor material, why we are studying about the direct and indirect band gap recombinations. So when we create switching devices, more important, बहुत ध्यान से सुनना इसको, most important part, जब हम switching devices बनाते हैं, so every switching device has a delay response, transient response, उनका खुद का response होता है. How much time it takes to make it on and off. Their example I've just taken in so many areas, like suppose you are just making your car door open, so immediately lights gets on, लेकिन जैसे ही बंद करते हो lights get dim slowly. Similarly, if you are switching off your television, so not all the LEDs are immediately switched off. You get there, the illuminations on your TV screen get slower down very slowly. So where you are having a different delayed responses, different switching responses, किसी चीज को एकदम से बंद नहीं कर सकते. कई बार बहुत बड़ी मशीन है, एकदम से स्विच ऑफ कर दिया, मशीन खराब हो जाएगी. एकदम पावर कट नहीं कर सकते. वी हैव टू मेक इट स्लोली डाउन. वहां पर हम इस डिवाइस का स्विच लगाएंगे वेयर इट हैज अ हाई डिलेड रिस्पांस. सो द डायरेक्ट एंड द इनडायरेक्ट बैंड गैप सेमीकंडक्टर्स जो होते हैं, उनके डायरेक्ट और इनडायरेक्ट रिकॉम्बिनेशंस, उनके स्विचिंग, ट्रांजिएंट रिस्पांस, डिले रिस्पांस, बिहेवियर्स को चेंज करते हैं, जिससे उनसे बनने वाले लॉजिक गेट अलग अलग टाइप के होते हैं. दिस इज एग्जैक्टली द यूटिलिटी ऑफ स्टडिंग. हम क्यों पढ़ रहे हैं इसको, दिस इज एग्जैक्टली द यूटिलिटी ऑफ दिस वन.